In Level 2, you came across a concept called anti-differentiation, which in your calculus paper was the opposite of differentiation. In Level 3, we start to more formally come across this idea, and we call it integration. But the concept is still the same. Integration, at a really simple level, is just the reverse of differentiation. And to see the important aspects of this, we're going to first look at a really simple cases. For example, we might have two functions, one y equals x squared minus 3, and another one y equals x squared plus 5. If we were to differentiate these functions, we get dy dx equals 2x for both. Now, if we wanted to go back to the original function, we now need to apply integration techniques or anti-differentiation techniques to our dy dx equation. So now let's pretend we only knew that dy dx equals 2x. From NCEA Level 2, you learnt that we increase the power by 1 and then divide by the new power. That is, in essence, the opposite to the differentiation rules. So, y equals, we increase the power by 1, and we divide by the new power. Now, the one thing that this equation doesn't have, which the first two do have, is the first two had some sort of shifting constants. The first one had -3, which shifted the x squared graph down by 3, and the second one had +5, which shifted the x squared graph up by 5. In our current y equation, we don't have either. So because we don't know what it is, we're going to put a plus c. We're now going to simplify this, and we get y equals x squared plus c. This plus c is really important. It's called our constant of integration, and it allows us to account for the fact that different functions can differentiate to give the same gradient function. Now, to work it out, we need to know a point that this curve lies on. So let's just say the curve is touching the point 1, -2. So now we've got a point I can substitute into my equation and find c. So for example, -2 equals 1 squared plus c. That means -2 equals 1 plus c, so c is equal to -3 in this equation, which means that our full equation is y equals x squared minus 3. Now that should be a complete recap from Level 2. At Level 3 we start to introduce more formal notation, and so we're going to go over that before we touch anything else. I'm going to write the notation down first, and then we're going to look at what each bit says. So, we've got this weird little squiggly line. It's sort of like an elongated S. And what that means is it's an instruction, and it just says integrate. That's all it means. And we want to integrate this function. Now, the function that has not been integrated yet is called the integrand. In the English language, we often put the word and after something if it represents a group of people that is about to do something but hasn't done it yet. For example, at university, once you finish your degree, you will graduate. The day before you graduate, you're called a graduand, which means the group of people that have finished the degrees and are about to graduate. In this case, it is the function that is about to be integrated. The dx means with respect to x. So it's really just telling us, look at the x variable and integrate that. If you were integrating with respect to y, so maybe the function had y's in it, then it would be dy. If it was a bunch of thetas, then it would be d theta, and so on. That will equal capital Fx, well, that is the antiderivative of the integrand of fx, which means that's the function that's undergone the integration, and then we have our c, which is called the constant of integration. So when you see this little funny symbol, all it means is you should integrate now. So, a recap from last year, integrating powers of x. We talked about it before, you increase the power by 1 and then divide by the new power. And so if you had a function x to the power of n dx, we increase the power by 1, divide by the new power, and add c. Now it's important to note that in this example, n cannot equal -1. If n was equaling -1, we would get a divide by 0 going on, which we can't do. If there's a coefficient in front of the x power, for example, integrate a x to the power of n, where a is just a coefficient, it's a whole number, it's a real number. Where a is just a coefficient, it's a real number. Then all we need to do is essentially just ignore it. We're going to get a times, raise the power by 1, divide by the new power. I'm going to go through a few examples on the different cases that you can see at level 3 and how it's different to level 2. So number 1, really simple, dy dx equals x to the power 5. That means that y equals, we raise the power by 1, we get x to the power of 6, we divide by the new power, and we add c. Job done. Number 2, so we have f dash x, and that's equal to 3/5 x to the power of 8 minus 7. Well, to get fx, we're going to, for each of these, raise the power by 1 and divide by the new power. That gives us 3/5, then times x to the power of 9 divided by 9, minus, and when there's not an x, then we're just going to introduce one, minus 7x plus c. Simplifying, the 3/5 times 1 over 9, the 3 and the 9 can cancel to give a 3 in the bottom and the 1 on the top, giving us x to the power of 9 over 15 minus 7x plus c. It's really important that you're good and comfortable with fraction multiplication and fraction division in this topic. Number 3. Integrate 1 over 6 x to the power of 2/3 dx. Now, just like differentiation, the integration rules really only work if x is on the top of a fraction. So we're going to bring that x to the top, remembering that we shouldn't take the 6, we only take the x. So that is equal to the integrate 1/6 times x to the power of -2/3 dx. Now, I'll rearrange this, but I haven't actually integrated yet, so I've still got that integration sign. I'm only going to remove it when I've done my integration, which we're about to do. That equals 1/6 times, when we increase the power by 1, -2/3 plus 1 is 1/3, and I'm going to divide by 1/3. Now, dividing by 1/3 isn't that nice, and so we need to know that if you are to divide by 1/3, that is the same as timesing. We invert the fraction by 3 over 1, or just timesing by 3, plus c. That gives us 3 over 6, which is 1/2, x to the power of a third plus c. Knowing your fraction division rules is going to be very useful for simplifying the work you have to do. Number 4, y dash equals 1 over 2 x to the power 3 minus 4 times the square root of x. Well, just like in the previous question, we've got a x on the bottom of our fraction. Now we're going to bring it to the top. And when you have a third, you need to make that a power. So y dash equals 1 over 2 times x to the power of negative 3 minus 4x to the power of a half. Now we can integrate. Y equals 1/2 times x to the power of raised to the power by 1, we get negative 2. Divide by negative 2. Minus 4 raised to the power by 1, we get 3 over 2. Divide by the new power, which is dividing by 3 over 2, which is like timesing by 2 over 3, plus c. Simplifying this, we get y equals 1/2 times 1 over negative 2 is like negative 1 over 4, x to the power of negative 2. Then minus 4 times 2/3 is minus 8/3, x to the power of 3 over 2 plus c. And we can simplify this slightly more by bringing that x to the bottom. We get negative 1 over 4x to the power of 2 minus 8/3 times. And if you wanted to bring this back into the original third form, well, x to the power of 3 over 2 can be written as the square root of x to the power 3 plus c. Final question. Integrate 2x to the power of 4 plus 3 all over 4x squared dx. When we have just one thing on the bottom of our fraction, we can look to split our numerator into two parts. In this case, we get 2x to the power of 4 over 4x to the power of 2 plus 3 over 4x to the power of 2 dx. Now you might see in some questions this might also have a bracket around it. We'll explain more in detail later why that is the case, but whether it does or doesn't, not super important. You will get questions with both. Now we can simplify this. 2x to the power of 4 over 4x to the power of 2 gives an x squared on the top and just a 2 on the bottom, plus 3/4 times, and we're going to bring that x to the top by making it x to the power of negative 2 dx. Now we can integrate. We get raise the power by 1, 3, divide by the new power, 3. When you're dividing new power to this, that's just like timesing it to the bottom of our fraction, plus 3/4 raise the power by 1, divide by the new power, plus c, gives us x to the power 3 over 6. That negative 1 just makes us a minus sign, 3 over 4, and we can bring that x to the power of negative 1 back to the bottom of the fraction by changing its sign to a positive, so 4x plus c.